It is exciting times that we're living in right now. It seems like every other day there's new developments and news coming out of the space industry, which, if you're anything like me, which you probably are seeing as you're watching this channel right now, hearing that sort of news is always exciting. Now, I don't know if I ever actually wanted to be an astronaut, but for those of you who do, you've got to have a set of very specific characteristics which we've all come to know as the right stuff. Now, people who actually have this right stuff are few and far between. So the question is, could we use modern technology like genetic engineering to make it less like finding a needle in a haystack and instead actually make somebody have the right stuff? And to take that idea a step further, if we could pick and choose what genes somebody has, what would the ideal future astronaut be like? Some astronauts say that when they're in space, their legs become pretty useless pretty quickly, so having something like hands instead of feet, or potentially even a tail that can grab onto stuff, would be really useful instead. Now, these ideas are obviously really far-fetched, and for the moment at least, they're just thought experiments. But the ideas do raise a really interesting point. As humans, we evolved here on Earth. Over millions of years, we've been shaped and moulded by the environment that we found ourselves in. But space is a whole other environment altogether, which brings with it a whole bunch of new problems. And this is important because right now, the world is looking towards setting foot on and hopefully colonising Mars. And even for a trip like this, which in the grand scheme of things is relatively short, we're going to have to do some real problem solving to ensure that we can survive the journey and survive on the planet itself. Now, when we talk about living on other planets, a thought that comes to a lot of people's minds is something called terraforming. Let me explain. Terraforming is where we would be changing conditions like the atmospheric composition or the temperature of the planet to make it more suitable for sustaining human life. But with today's technology and with technology that's likely going to be available in 10 or 15 years, this just isn't going to be possible. It's not a feasible solution. Instead, we're going to be relying on things like man-made artificial habitats and other technology that's going to help keep us alive. But even with this technology, there's a whole bunch of problems that we're going to have to solve. And this is exactly where genetic engineering might be able to step in. We might be able to give human evolution a little bit of a nudge to speed up the process and adapt us to the new environments instead of adapting them to us. So the question is, what are the problems that genetic engineering like this could help solve on a trip to Mars? One of the biggest problems facing astronauts on a trip to Mars is high energy particles, which we call radiation. In space, it comes from many different sources and can be both dangerous for spacecraft and the astronauts that are aboard. Radiation can damage things like solar cells and sensors, but the real concern comes from the damage that it can cause to human DNA. These energetic particles can pass right through the skin of astronauts and damage the DNA, which can increase the risk of cancer and can cause radiation sickness during the mission itself. On Earth, we're protected from this radiation by things like the atmosphere and by a huge magnetic dome around the Earth, which we call the magnetosphere, which literally deflects the majority of these particles. But outside of this area, like what astronauts are going to experience during a trip to Mars, the levels of radiation that they're going to be exposed to and the actual type of radiation is much more dangerous. And what's worse is that the planet that we're looking to call a new home doesn't have a magnetosphere, and it also has a much thinner atmosphere than Earth, so we won't be gaining too much protection from it once we're actually there. So outside of actually improving the technologies that can actually stop the radiation from reaching the astronauts, genetic engineering might be able to help make these astronauts more resistant to the radiation itself. There are many organisms on Earth that can withstand much higher levels of radiation than we can. And there's extensive research going into finding out what genes might be involved in allowing them to do this. But currently there's a team of researchers taking their cues from an animal that you're probably more familiar with: elephants. These researchers are looking into the effects of increasing levels of a gene called P53 in human cells. P53 is known as the protector of the genome, and elephant cells are loaded full of the gene. And what's interesting is that elephants don't really develop any sort of cancer. So the thinking is that if we increase the levels of P53 in human cells, we might be able to reduce the risk of any tissues becoming cancerous if damaged by anything like radiation. But even if this research is successful in solving this issue, prolonged space travel does bring with it another problem, which is prolonged exposure to reduced gravity. In these conditions, astronauts have been seen to experience things like nausea, deteriorating eyesight, and weakened immune systems. And on top of this, their bones and their muscles actually weaken by quite a large amount due to the fact that they don't really have to do much to work against the effects of gravity. Now, Mars' surface gravity is only around 38% of what we have here on Earth, so it's likely that these same effects will happen to the astronauts that head to that planet, just at slower rates over extended periods of time. So what can we do about it? Well, it turns out that genetic engineering has a few hopeful solutions here as well. For instance, a gene called LRP5 has been shown to increase bone density, and a gene called MSTN has been shown to lead to unusually large, strong, and lean muscle, which could offset the effects of muscle weakening and muscle loss. But after this, you're going to need food to help actually sustain this muscle and bone mass. And a surprising problem that we're going to be facing with Mars is actually to do with nutrients. Now, you've probably heard of things called essential nutrients before. These are nutrients that the human body can't produce on its own, so it needs to get them from things that do produce them, things like plants and fungi, for instance. The entire process relies on complex ecological systems, and with the ecology of Mars not being exactly like what we find here on Earth, and with terraforming or the idea of bringing an entire ecosystem along for the ride not really being on the cards, this is where genetic engineering might step in again. Now, I'm not talking about making a big green photosynthetic human that can get everything it needs from the sun like plants do, but there might be a way to make humans pretty much self-sufficient when it comes to most nutrients. Researchers are actually looking into the possibility of altering kidney cells so that they can produce essential nutrients and vitamins. And they're currently starting with one that just requires a single gene, but they're pretty confident that with further research they could make these kidney cells produce a load more. This could have massive benefits for long-duration spaceflight and a trip to Mars, especially considering that food supplies could be simplified because the astronauts' needs are so drastically reduced. But my question to you is, would you want to survive on bland, potentially just sugar water for that amount of time? Surviving on that would be enough to drive anybody insane. Which actually brings me to the last point that I wanted to talk about: human psychology. For astronauts going to Mars, staying sane is going to be a real concern. They'll be having to cope with sharing a confined space with a group of people for years on end. They'll have to be able to be social and also be comfortable being alone, depending on whether or not people want to hang out with them at any given moment. And they're also going to have to deal with the exhausting lifestyle and the tasks and the problems that all come as a part of a package with a trip to Mars. And they're going to be doing all of this whilst also separated and isolated from all of the loved ones that they left back on Earth by millions of miles. Now, certain genes have been identified which could help us to achieve the ideal personality for a trip like this, including some which are associated with lower anxiety levels, as well as higher problem-solving capabilities. But the thing we have to remember is that personality is an incredibly hard thing to control, especially considering the fact that we're really just beginning to understand how genetics can affect personality, and we really just don't understand the consequences that messing with genes like this might have. So clearly there's a lot more research that needs to be done before we really consider tinkering with genes that might mess with the personality of a future astronaut. If we're going to go to Mars and colonize it and live there for several generations, evolution is going to occur in the population, whilst they adapt to their new environment, separated from the population of humans left on Earth. Over a long period of time, it's likely that the population is going to become very different, and that's even if we don't use genetic engineering on them before they go. This whole topic raises some really interesting ethical questions about whether it's right to be messing with the human genome, and then to subject even future generations to these genetic changes when we don't really know the long-term consequences of them. But then another way you could look at it is that if we have the ability to optimize these brave men and women that are going to be increasing the reach of the human race, is it our ethical duty to make sure we do that? But the question I'm left with is, how far could we push genetic engineering of astronauts before the people that we're sending off to space can't even be considered humans anymore? So that is it for this episode of Aspect Science. Let me know what you think about genetically engineered astronauts, genetic engineering, or space travel in general down in the comments. Comment, like, subscribe, do all the things you gotta do. I really do appreciate your support and hope you enjoyed this video. So until next time, I'm Tom, you keep discovering the world around you, and I'll see you then.